I want to know if these three numbers can represent measures of the sides of a triangle. So what I'm going to do is use the triangular inequality, or the triangle inequality for this. Okay, the triangle inequality tells us that the sum of any two sides is greater than the third. So that means if I add any two of these numbers, it needs to be bigger than the third one. So if I add 7 and 2, that equals 8. Well, that's less than 10. So for the triangle inequality to work, 8 would have had to be greater than 10, and it's not. So no, this is not possible. If we were to draw segments with these lengths, they wouldn't be able to connect to make a triangle. So here I have two sides of a triangle, so I want to find the range of possible values for the third side. So what I'm going to have to do is use the triangle inequality that tells me if I sum any two sides, then that sum should be greater than the third side. So that means 36 plus 48 should be greater than the third side, which I'm going to represent by the variable x. Also, if I add either of these with the variable x, it should be greater than the other. So 36 plus x should be greater than 48, and 48 plus x should be greater than 36. Well, this is always going to be true for any value of x, since x has to be positive because it represents the length of a side. So this is always true, so we don't need to use this one. Okay, but we will use these two. This one is 36 plus 48, so it says 84 needs to be greater than x. And this one, if I subtract 36 from both sides, I'll get x needs to be greater than 12. Okay, so 84 is greater than x, and x is greater than 12. So if I were to write this in a compound inequality, I'd have 12 is less than x, which is less than 84. So x needs to be between 12 and 84 exclusively. It cannot equal 12 and it cannot equal 84. I want to find the possible range of values for the third side if I know these two are sides of the triangle. So what I'm going to do is use the triangle inequality that tells me if I sum any two sides, it's going to be greater than the third side. So that means if I add 7 and 9, it has to be greater than the third side, which I'm going to name x. Also, if I take this side x and add it to either one of these sides, it must be greater than the other one. So 7 plus x must also be greater than 9, and 9 plus x must be greater than 7. Well, the nice thing about this one is since x needs to be a positive value because it is length of a side, then this is always going to be true, so we don't need to use this one. Okay, so these are the only two we need to worry about. So if we add these two numbers, we get 16 is greater than x. And if we subtract 7 from both sides, we get x is greater than 9 minus 7, which is 2. Okay, so if I combine these two statements into one compound inequality, I have 2 is less than x, which is less than 16. So the third side needs to be between 2 and 16. It can't equal 2 and it can't equal 16, but it does need to be between those two values.